Hi, Shri.
Hey, Shiva.
How are you?
How are you?
Very good.
Good. There's some changes you see. The
Yeah,
buttons have changed.
the API also has changed.
Oh, is it?
Yeah, I mean in terms of, in general, I think if you see all the buttons, I think I see change in the entire look.
Yeah,
Anyway, it looks nice.
Yeah, it's better. It looks more solid. Yeah, I saw the mail that he sent with a lot of details about the features. I read a bit of them. Some of them I had seen before. So, yeah. Okay.
Cool.
That's great. So there is a sale going on, is it, for in Udemy? I saw. I took a couple of courses. We'll see how it goes.
Udemy is on sale for large amounts of time. Per month, I would say almost half the time it's on sale.
Yeah, I see now, but because when I once checked, when you first told me about this Precipitation, this course on Python, and I went and saw it was like 170 euros. I was like, no, I'm not buying that. And then now it was like 11. But though I got another one, which was more on a little more advanced. It says Jose's course was a lot of time he was spending.
Yeah.
Hi, Harish.
Hi, Harish.
Let's see.
All right, great. So before we start anything, any comments from anyone?
Yeah. From me, not much. I will probably talk about what when I spent a few minutes or maybe half an hour, 1 hour on that Liège data that we are working on. But that I'll probably talk about. Otherwise, I don't have anything specific. Though I can ask a few questions, general question I will ask. Harish, do you have anything for us?
No, actually I'm not spending on the programming because of hectic schedule in other testings. So
Okay.
maybe
You are at work now?
Yeah, I'm in lab.
Okay.
But it's safe.
Okay. I mean, the question I had was, this is just because you do some web development, so I just wanted to ask. So, when you develop these applications, the portability from one platform to another. So, for instance, if I write a code in Python, and if I want to create an app on Android, because of course Android is mostly written in Java and it's an API or whatever. And for now, until Oracle wins the suit, Google will be screwed completely.
Yeah.
But anyway, but then I also see that some people have courses where they say, okay, you'll do some Python and then some web development and then Android development all together. So, how does it exactly work when it comes to developing apps? And,
See, it's like this. When you talk about an app, there's one is you can have a native app. Like for example, it's an app you actually install on your mobile. That's like WhatsApp or Facebook or Instagram. So that could be written in anything. Typically, it's usually written in Java, but then again, you can also write it in React Native. You can write it in Angular Native. There are several platforms. There is also something called Flutter. Flutter is getting very popular now. So these things are there. Now, that usually is the front end. Whatever you do, like your WhatsApp, everything, that is usually the front end, gives you the UI. The buttons, you click on it, what happens, all that. Now, whatever you do to actually get any functionality, you would have to access a backend API, which is generally a server. So if it is WhatsApp, you're sending a message, it basically is a request sent to the server, which in turn will send it to somebody else. So that is the front end and the back end part. Now, the back end can be Python or anything. It has nothing to do with the device. It could be a browser. It could be anything. It sits on a server. Now, as for the front end, the simplest way to get started is using a web app. So that way it's just, whether it's a mobile, whether it's an iPad, whether it's a desktop or a laptop, you will have some kind of a browser. That is, either you'll have Google Chrome or you will have Apple will have something else. I don't know what it has, but it will have some kind of a browser. So in that browser, you just have to basically access a website. Again, that is something sitting on a server. So you could have an entire app with a front end and a back end without any Java, like without any native app, everything just on a website. So there's one server that's hosting it, that provides backend functionality as well as hosts the front end, and you just have to access, like facebook.com on your browser. You are accessing it on a server.
Okay. Yeah. Okay. Yeah. That probably is.
Where it becomes difficult, like for example.
People
Yeah. No, go ahead.
No, that's why probably when people talk about, okay, you have Python and Django, and then you develop a web-based application. And so essentially what they would, when they talk about that in Android, it will be a web app kind of setup.
Well, it's in Android, it's like this. Only time when you would go to Java or React Native is when you want to use the mobile functionalities. Like you want to use the mobile GPS, you want to use the mobile Bluetooth, or something like that. You want to use the mobile camera. Then you probably might have to use Java. I don't think you can have an app sitting on a server which will access, though, like for example, this what we are using now with Howdy. This is an API which asks the browser requests the browser for access to your microphone, access to your camera, everything else. So there is some way to do that also, but then it's probably better to have an app because you can access everything in that case.
Yeah. I see. Yeah. Okay. So we will go to the data.
Yeah, sure.
I'm going to share my screen, and I just did a few things. I found a way to do some how do I say, resampling and all that, and then so I think we were somewhere here. So what we did was we created this lambda function prime underscore drop. What it essentially did was
it just converted the string to an actual datetime object.
Yeah. So what we did was we used that on two of our data sets. One is the weather data, another is the PV data, that is the PV solar generation data. So one of the issues that we had was this synchronized data. So, and also what we did was we removed those parts of data which were not available on all the data sets. So we focused it between 20th of May to 17th of June. So we ensured that the data is between that. And so after that, what I did was, so I was trying to look at this thing called resample. So resample, what does it do is it helps, depending upon whatever parameter that we give, it helps to resample the data, provided the index is a datetime object which can tell you what exactly should it. So what I did was I actually modified the index. I set index to this datetime object that we had, and then so essentially I can just so we get have this. Now this is the daytime object, and this time has moved as a column. And similarly for TV, again I did the same thing. So you have this. So after that, and I also applied sum, in the sense that I don't want the consumption or the generation of data, generation of energy during that period, I don't want it to be missed. So I was thinking of an average, but I think sum makes sense for consumption. And then anyway, I couldn't find anything called average, but anyway, sum.
It's mean actually. There is no average. It's mean.
I'm sorry?
The function is mean.
Yeah. I think even mean was not there.
Oh, is it? Okay.
Yeah. I was checking something like that. Let me just see. I don't remember now. Let's check. No, there is no mean. So there is sum. Okay, let me see.
I think you have too many notebooks open.
There, yeah, mean is there.
Okay.
Yeah, mean is there. Okay, yeah, I should be there. Okay, fine. So anyway, but sum makes sense because anyway I tried a mean mechanism anyway. It's not, but then I saw that it's not. So more, I think sum makes sense because we are typically the average temperature is fine, but we have to see how much time for over that period of time how much power was generated.
So resample 15t means what? Resample only a 15 minutes time period? What is it? 15t?
Yeah. I think 15 minutes.
Can you do a shift tab inside?
Yeah. So this is the rule that is there. So rule would be okay. So you can say data offset time delta or string. The offset.
It does take a string. Okay.
Sorry.
It does take string also.
Yeah.
Okay.
So I found it in an example and it worked for me. Yeah.
So 15t. Can you come down? Let's see if there's an example.
Yeah. The example was 3t, I think. Yeah. So the example here is 3t. So there is 3 minutes bins.
Mm-hmm.
And so you get once in 3 minutes. So I just said, okay, for me I needed 15t because previous one was in 15t. And there are a few other things which worked well for other parameters which I didn't have to change. Like when does it start? Things like that. Should it start after a few samples or on the start? But all of them are fine for us. So perhaps mean should also be fine for us.
No, sum seems better. The reason is because otherwise you will lose data. Because in a PV, you are recording every, 5 seconds or 5 minutes? What is it?
Yeah.
So therefore, in that case, you would need to actually find out the total PV generated between these two samples. Because finding the mean won't really make sense because it's continuously increasing on the total PV generated rather than just mean. Yeah. So
what I did then was I just created a concatenated data set where I would remove also the time piece. So essentially I will have a data set named DF PV weather, which contains the PV and all those weather parameters. And the time is the daytime.
Okay.
So this is what we have, and now we'll probably have to do some form of a group by, I guess, to do some analysis of how something affects the other and things like that.
Okay.
So for instance, I will just quickly probably say, maybe we can now decide which of these, because these are the different variables that we have that we have here, and we can decide which one of them we want to use to do the analysis.
Okay. So first is, let's look at CD 0 to 1. Precipitation is a common number. Relative humidity is percentage. Snow height is in millimeter. Surface temperature degrees Celsius. Okay, so one thing here, if you see, is it's almost completely quantitative data. Right?
Yeah.
So the problem with completely quantitative data is, if you want to do any kind of sorting, we first have to, we first have to sort of categorize some of the quantitative data into categories. Like for example, let's say the first one, low clouds, right? It is between 0 and 1. So supposing you were to plot that one thing, right, that's low clouds, over the entire time period. Are you typing anything, or is it coming?
Yeah.
Okay, so okay.
I think there is a problem with the amount of screen it is sharing.
Okay.
So earlier it wasn't a problem. I realized that now when I came back to see what is being shared, I see that there is some problem with the amount of screen it is sharing.
I think that's just because we have like a small window, and there is another part of the window where our people are, and then there is a call button thing, so that's only, I guess, expected, I guess.
So I'll probably push a few more. Now probably will be better.
Yeah.
Yeah. So okay. So maybe I'll have to increase the plot size.
So you can plot first and then no problem.
Yeah. It's okay.
Okay. So it is between 0 and 1.
So maybe it's more, we'll first see what are these values that are there. Maybe it is just not.
Yeah, I doubt so, but try it out. Yeah, everything. So what it is like, for example, given one example of this, let's say, for example, since we are between 0 and 1, we can divide it into 4 regions. Example.
Yeah.
So like we have between 0 and 0.25, we call it low. We have between 0.25, it's between these 4 sections. So we have low, low medium, and high.
Okay.
Right? So I'm assuming 1 means it's very cloudy or it's completely cloudy, and 0 means there is no cloud. Just check once, is that the case?
Yeah.
Low clouds.
Low clouds, medium clouds, and high clouds.
So 0 means low clouds, it means it's completely sunny. 1 means it's probably high clouds.
No, well, let's just check, because I'm a little confused. What is the size? How do you change this plot dot?
Figure, plot dot figure, and then in brackets fixed size.
10, 12, or something like that. And then I'll also plot the other one, because I want to see if they are really related.
Okay, the PB.
Yeah. No. In the sense that because we see that.
Okay. They already have it. Okay.
Yeah. I mean, I'm just confused, because if it is completely opposite to each other, okay, I think I'll have to change the. Do it. I maybe, and then no, it's 12. I'm sorry, there's some I understand. Yeah.
Okay, so how do we find out?
Just CD, which is low cloud, and CM is medium cloud.
Okay, can you do one thing, like put an X, but then how will you know? Can you know? See, I'm just thinking if you can put like an X limit. So like, for example, if below this you say plt.xlim.
Okay, you want to xlim it.
Yeah. And then what do we say? How do we give the x limit? Because it actually has to be a total datetime object. So supposing you put, no, I want to say, supposing we play, if you come scroll down a little and you look at that plot.
Yeah.
So you see between that 2019 0525 and 2019 0529, there is quite a bit of activity.
Yeah.
So we can kind of zoom in between that to see how it works.
Okay.
So then maybe you have to then specify two date time objects.
Maybe here I can actually, yeah, we have to specify two date time objects. Okay.
Yeah.
Date time.
Maybe 2019. Yeah. No, you just have to specify something. So it's okay. So 2019 5.
Yeah. I'm just.
Since you're specifying an integer, it's usually okay because it's an integer. But anyway, 25.
No, this is 24.
Okay. Okay, very nice. Okay, so now they do seem the opposites of each other, but they are not actually like 1 minus this. What have you plotted again? Is it high and low?
Just a second. Okay.
If you go up and see what the command is. Okay. So it's, yeah, so it is, what is it? Medium and low. So maybe do CD and CU. So second one can be CU instead of CM.
You want to see you?
Yeah. Okay, so now it does seem like it's actually 1 minus this.
Yeah, exactly.
Okay.
Almost. Because there are some weirdness here, but
okay. So then, I'm just thinking, how do we use it? So they have given us low cloud, high cloud, medium cloud. What could we possibly do?
are they related to the position of the clouds? Because there are these clouds which are pretty high up in the sky, and are they related to that? I didn't find a lot of details about that.
Oh yeah. Yeah, it's tough to find out.
Well, yeah. Anyway. So let's say that as you said, we will just.
But again, I'm just thinking. If you look a little here, just scroll down a little. Let's have a look. See, there are times if you look where they don't actually seem like 1 minus. So they are like actually captured independently. There are times when it seems accurate. There are sometimes it doesn't seem accurate at all. So I'm just trying to wonder if what if we were to take this 3 and collapse it into 1? That is, if we take these 3 and try to collapse it into one single thing of cloud, is it low, medium or high? So that is, instead of having a 0 to 1 for 3 columns, you have just 3 possibilities. So let's say 0, 1, 2. 0 means low cloud, 1 means medium cloud, 2 means high cloud. Okay. So now what that means is, let's say for example, you can look at it as a kind of a probability because it's between 0 and 1, right? So I'm assuming if it is 1 means it is high probability of low cloud, and if it's 0 means it's low probability of For example, let's say, but just for low cloud, that is CD. If it is 0, that means it has a low possibility of low cloud, right? Low possibility of low cloud means high possibility, or rather, what do you call it? A low possibility of high cloud in that case, or how is it? High possibility of high cloud, right? So, in that case, if we were to map all these three, right, can we come up with an equation where we can plot like a kind of an aggregate and where it is? Okay, so what I'm thinking is this. Supposing, for example, we were to come up with a simple algebraic sum. Okay, we take all these three, we add it up, and we take the mean of them, right?
Okay.
So, what if we were to now compare that, right, with our actual thing? So, let's say we do this. We create a new column called cloud, and we add all, we take the mean of the others. I mean, if it doesn't make sense, we'll drop it. Doesn't matter.
I'm sorry?
If this doesn't really make any sense, we'll just drop it and start something else. So it's okay.
Yeah. That's fine.
Actually,
Can we do something like mean of something like this?
you can do np.mean. So it will be np.mean.
But I think these three are mostly okay. Let's say this. No,
Oh, is it?
D-type is not supported in the Python implementation.
Oh, it's just that we have, okay, it needs at least this thing.
Okay, so maybe I will just do something like plus okay, there's an extra mistake. Yeah, I can see this. Okay, let me see. Yeah. So we have it.
Supposing you now add this to the previous one, and let's plot it together. That is this.
So you want to keep them together?
Yeah. Let's see. Doesn't matter.
Yeah.
Oh no, you need the zoom in, otherwise it won't make anything.
Yeah. Yes. I'll just check.
Okay, so now what if you were to add the medium also? So CD, CU, CM and cloud cover. Alright, so okay, now can you just put like a legend, because I'm kind of getting lost. So just do plt.legend at the bottom, and actually you might need to put like a label to each one, because you need, so first is at the plot above you can just put CD label. You have to say label is equal to and there is a extra comma above, yeah, and then we have to put a legend. You'll have to say plt.legend and a parenthesis, yeah. So our red line is the mean. Now if you look, quite surprisingly, if you look, the blue line, which is low cover, and blue and green seem almost different, like almost almost anti of each other, which is expected because one is low probability, the other. Now the mean is something very different.
Yeah.
Right? The mean is very different. So I'm just wondering, this mean, if you were to check out, can you go up and have a look again? Is there a description still of this?
The data?
Yeah, the mean. Yeah, if you go up and have a look. Medium clouds.
So it's not a mean cloud, right? It's just medium clouds. So my guess is this: these three clouds have to do with the height at which they occur.
That might be. That might be.
That's why they have to be. They are different. So for us, perhaps it may not really be a problem that the cloud cover is low, medium, or high. So we can probably say instead of taking, say, the average, we can actually say the maximum, I would say, because that way what it happens is that if there is a cloud cover, we'll take the maximum of it, because that's the maximum amount of cloud cover that can be there, whether it's low, medium, or high.
Exactly. You can just do that.
Yeah. So, okay. Now,
or if you want, of course, this can come later, but I suppose low cloud cover would hurt a PV panel more than a high or a medium cloud cover. But it's hard to say. You have to actually get into like actual weather info.
We will see.
Yeah.
Maybe perhaps we'll see. Okay. Let me just see. Let me try this now again. Okay. Sorry. So when max comma. Okay, it's ambiguous. Okay, I think
what I would say is just quickly just do a lambda, I think. You can just quickly do like a little lambda function. Or just apply, just create another function.
Yeah, okay.
You could name it something. So like for example, call it process clouds or max clouds or whatever. So here lambda x colon is equal to, now all you have to say is x return, how will you say this?
Oh, sorry. So you have to send so x of c.
No, here I think there will be a max. Yeah, there will be a max thing. So you can just say m.
X of cd.
Yeah.
Comma x of cn. X of CPU. Okay,
and then here you'll have to actually say and then apply. And before you do, you have to say the access properties. You have to say access is equal to 1, because now you are processing multiple columns as opposed to a single column. So for example, if you say access is equal to 0, you don't specify it, it will give you an error. So like
okay, we'll try. We'll just yeah.
Okay, because the reason is it is saying it doesn't know what these columns CD are. So when you say access is equal to 1, then you're telling it, don't just go along the rows, also have a look at the columns.
Okay. So I'll just do here. Okay. So yeah, the red one, which is the mean, or it's not the mean, maximum. So it's essentially now kind of creates a sort of a top envelope.
Yeah. Okay. That's all.
So I think this is good. Then we have precipitation. I think there is nothing much we can. So do you want to make this a categorical variable? Right now it is, I think.
Well, okay, let's have a look. So let's say, for example, if you look at the precipitation, let's say we plot the precipitation. You can create another plot altogether.
Precipitation, I was talking about cloud cover because we are still there in cloud cover.
Oh, okay. So
because cloud cover we had so right now I think right now it would be pretty different. Like, let me just quickly see if it has become different or not much, but I think I mean it's again still about quite a number of different values.
So again, if you want to do that, so we can technically sort of categorize it in different types of cloud cover and then do a group by.
Yeah.
So what you can do, yeah. So for this, what you have to do is basically we have to now again create another lambda function. So it's, or you can create any other kind of function. So this probably won't be a lambda because you have to categorize it into different things. So now.
So there is a mechanism to categorize convert it to categorical variables, right? Given some, I think it is there in pandas. I forgot.
Yeah, you can Google. Just check. Have a look.
Yeah. Okay, so it will be a 0 to 1 categorical, I think. Because here it says there is a thing called categorical. It just, but I think it will only do 2. Maybe I will just check what way. See, it's nothing. Okay, maybe it's a time series, that's why it's not coming. Let me just move it. No, it's not coming. Okay, I can just check. Say PT. Oh, okay. So it's in PD category.
Oh, it's just it's something in pandas itself.
It's more general. Okay.
So now you have to specify the actual, that is DFPV cloud cover. PVFPV by the cloud cover.
Okay, now I'll try to. Sorry?
Because the values will be that column itself. So that is DBPV, DF. If you go back to the Google, it just says that whatever is the column that you want to convert to categorical, you just specify.
Yeah. That we do, but I was just keen. So it says now categories is none. I think we'll have to give the number of categories or something like that.
Okay.
Because right now we don't want it to be like 1 or 0.
Yeah.
We want it to be, say, 3 or 4. So unique categories. Not given the categories are assumed to be unique values of values, sorted if possible. Otherwise, in order in which it appears. Values of the categorical. Okay.
Oh wait. Values of category values.
So values we don't have to give because I think that is. So we just give our. So we have values, which is what we'll give.
See, the only argument which is necessary is values. So if you go to the Google page, you'll see that he specified only one. So that is the values. df.ismail is the values because the others are default options.
Yeah. But if you see this, it has a category. I think it is 1 or 0 category.
Mm-hmm.
So, for instance, we'll try that. We'll just see what it gives us. So it will be df weather dot cloud cover. So it gives us 99 categories.
Oh.
So I think we'll probably have to specify something here.
Yeah, let's specify. So just try it out again, categories. So if you say categories and you put a list of, let's say 0, 0.25, 0.5, 0.751, what happens?
Let's see. Okay.
Okay. There are a few not numbers, but then we'll figure that out later why. Basically because they didn't have cloud cover for some maybe. So anyway, let's have a look at what this is.
I will just check because I'm just curious if they have an example with categories. Yeah. Okay. No. Look, I think it's looking at exact values. I think. You see. So categorical, you have ABC, ABC, and then you say categories as CBA.
Okay.
And so I don't think that's categories is a good idea.
Okay. I think we are
looking for exact values.
Yeah. Okay. That makes sense.
Yeah. So, but perhaps what you should do is maybe if we have to find if there is a way to give a range, because categories doesn't seem to be that.
No, I think we have to just create our own simplest way. I don't think it won't work.
Yeah. Yeah, okay. So it's probably some sort of a function that you'll have to do.
Yeah.
Okay, so do you want to do that now or do you want to check other variables?
Whichever you want.
Okay, let's do this then.
Yeah.
So
I would say just define this thing. What do you call it? Define an array. Define a variable, not an array. Define a function.
Yeah. Okay.
You need to specify a variable.
I'm sorry?
X. You need an X or some variable.
Yeah.
Okay. So here what you will have to do is you'll just have to have a number of if then statements. That's the only thing.
Yeah.
So we just have to say if X basically.
So do we say X of cloud cover or how do we say it? What will it take?
No, because in this case it's only one thing. So therefore you will pass only that. So you don't need to specify.
Okay. So then I would say if X is greater than 0.0 and
okay.
So you can use and?
Yeah, you have to use that and yeah.
Okay.
That is only for these queries here.
Then
return 0.
Yeah, return 0. Yeah. And then elif one.
You probably have to scroll down a little. I think it's gone off the screen. Yeah.
I see. I just I think we'll have to tell this to the RIS because this is crucial for because the amount of window that is displayed has actually shrunk.
Yeah, I think we maybe need to see it in a maybe these buttons should, because I think the buttons are sticking to the bottom. Before they would only come when you move the mouse.
Yeah.
But now I think they are stuck to the bottom. I'm not sure why.
Yeah.
Okay.
Yeah. So yeah. I'll just stop the video, but anyway, I'll continue with this.
Mm-hmm.
Okay, so I think this is fine. So we'll have to now send it through, right?
Mm-hmm.
So, but we can do an apply here.
Oh yeah, sure. So basically, what you can do is you can create another column, and then just drop the original column. So this is, for now, this is it.
Okay.
Or if you are absolutely sure, you can actually keep the same name and just apply it so that it rewrites the same column.
Yeah, I see, but we'll create a new column for now, because I don't even know if we are doing what we are doing is right. So
yeah. So you have to say equal to, because this, no, you have to say equal to, because this is a new column. So
yes, I'm sorry. Yes. Okay.
no, actually you have to, okay, categorizing curve, that's okay. No, that's all fine.
Let's see how it is now. Yeah, it's there, I guess. Okay, so how do we ensure that this is not a float, and it's because I don't think I'm returning a.
Oh, I see. Well, that's actually NumPy. So I think will have to actually cast it as like, return. I think you have to say return int 0, yeah, something like that.
Okay, let me see.
No, because I think it is the way it is sort of creating the data frames. I think, for example, if you just select cloud cover, that category, it will say np.this.
I'm sorry?
No, if you just list out that cloud cover category new column, so it's just basically it will see, if you come down, it will say it's a float 64.
Yeah.
So now
I can do some, what is that, AS type? Or
yeah, something, just or you might have to Google, not sure. Yeah, AS type is below. And if you can say int 32 maybe. Or just say int 64, I guess. Int 64. Int 32 should be good enough.
Let me see. No, I think there is some cannot convert non-final.
Oh, so that is the reason why. Okay.
Okay, there are some.
So
we have made some mistakes.
So right at the bottom, actually what you can do, right at the bottom, you can just do an else and then say return whatever. So if it is not any of these, then you just say return, what should you return? I think if nothing is there, return 0, right?
Yeah, that's why it was struggling. Okay. So let me just see first without putting it. See what is there in this. Yeah, now it's
okay. So it just didn't know what to do with this.
Let me see if we don't need categories, because I think that's why it is putting. The category was stuck because of some.
No, it takes, what happens is that because there was an infinite.
I found the reason. I think this is the reason, because here I had x is greater than 0.0 and there was some 0.0.
No. I think what is the problem? It might also be the case, but there's another case was that it was because of there is infinite and NaN in those, some of them.
Okay.
So those will need NP60 float 64 for resolution. That is, NumPy will need float 64. That is the reason why the whole thing was cast as float 64.
Okay. Yeah, I see. Okay, so this is done, and so we don't need this now.
So you can just plot it. Have a look and let's see what you get.
Okay. Just a cloud cover, right?
Yeah. Actually, you can copy that parts, just 2 parts. We don't need all of them. I mean, you can copy all of them and just delete the rest because we have xlim everything.
Yeah.
And
I will just put the category.
And we can remove the rest of it because it'll just be a mess. We don't need those CDCMCU. So.
Yeah.
Okay. Okay.
So there is a lot of cover in Belgium. So not surprising.
Yeah, hardly ever is there like. Yeah. Okay. So let's see what it is. If you see, actually no wait. If you see between, can you check between July? Do you have data between, or just say for July? So let's say, for example, if you say.
No, we don't have July. We just have May and June.
Okay, so then June, let's say between June 1st and 15th, what happens if you do that? I'm assuming it will be a little better.
Yeah, we'll see.
So you see, at least the sun is peeking out a little.
Yeah.
And what happens if you do 15 to July? This is up to July 1st?
No, 17th of June is the last data.
Then I don't know why. I mean, that's such a bad time to do because between May and June.
Yeah, that's the spring is when it's going to be raining.
Yeah, it's kind of weird. You want to collect.
Anyway, they appear to have been able to generate some PV even during this period. At least.
Actually, PV does not need that much. If you look, PV will also work with diffuse sunlight.
Yeah.
Okay. Okay, interesting.
So, what else now we have is precipitation, relative humidity. I think humidity may not be that much of an issue. And snow height. My guess is May, June, there won't be much snow, so we can remove that.
Yeah.
Then, so we'll probably not consider 5 and 6. And then we'll see surface temperature.
Is quite important actually. Surface temperature is very important for this.
And then irradiance. But what is a global horizontal irradiance? I don't know what it is.
Basically, there is incident radiation and what is absolutely on the surface. So basically, you have your PV panels which are usually placed at some kind of an angle, and you have the sun which is being measured directly on the surface. So for example, as the sun moves during the day, the angle will be different as it falls on the PV panel. So this one does not take into account the actual angle of the sun as it hits the PV panel. So that is the only thing. So the second one, if you see, total solar irradiance at the top of the atmosphere. So it is kind of one, take into account that this is what is coming all the way to the earth, and finally what eventually makes its way down to the surface.
Yeah. So perhaps we can probably ignore the total solar irradiance at the top of the atmosphere.
Yeah, that can be ignored.
Then temperature 2 meters above the ground, definitely.
Yeah.
And wind speed, perhaps 10 meters from the ground.
Again, I don't. No. Wind speed will not matter that much unless it actually makes your temperature drop. The biggest thing is your temperature and your solar radiation.
Exactly. So the correlation would be there anyway.
Yeah, exactly.
The temperature and So okay. So we'll probably now fix on temperature 2 meters above, surface temperature, global irradiance, and precipitation. Okay, so
good. So now that we have these data, I would say the next logical step is to try. Okay, now if we were to do something like linear regression, right, and try to sort of predict how much PV is there from the weather, and try to compare it with the actual PV that they have reported.
Yeah.
So now we could, one is, what if they've done the same thing? Then it may not be right. But do we know that? Or have they come across
in fact, they have done it, done something like this with recursive neural networks.
Okay, so at least theirs is a slightly more complex process. A linear regression will be fairly simple, because a linear regression is basically you are taking the output and you are trying to fit a straight line, which is not going to be very accurate, but that's good enough. We can just play around with it.
Yeah. So
one thing we can do is, so
do we try it with these parameters?
No, the first thing which I want to see is, like, for example, now we have combined PV weather. Like, if you look at PV weather, if you look at the data frame again, so the first column, that is PV, is what has been fetched from the other data, right? That is the PV.
Yes.
So we have combined. Okay, very nice. So now, can you plot just the PV? I mean, you can copy the stuff from above as usual.
Yeah.
It'll have to be equal to okay. So now, just to see, it's okay. One thing is, we have a very nice cyclic pattern, which is very nice. Now, if we take, let's say, one day, let's say June, 1st June, and do it from, let's say, 6 o'clock in the morning till 10 p.m. at night. So it will be 2019, 06, 1. And then we have to put, let's say, 6. So it's 600. And then the next one will be pretty much the same thing, except for 1000. Okay, now
perhaps you can put it like 1800.
So yeah. See. Oh, sorry. 10 is, of course, 10 is actually 10 p.m. You need 18, right? Or you need 20, you 22. Yeah, 22 will be right. So take 4 a.m.
Yeah, 5, 4, 5. Yeah.
Actually, if you go to, I'm surprised the sun actually rises that early. Right? Okay, so at least now we know that this is PV data, which is actually seems fairly, what do you call it? Understandable PV data over a day, right?
Yeah.
Now, what we would like to do is, we want to now be able to create another column of PV, right? And then fit it with this. So, like, we want to compare what our predicted PV will be from the weather and check how it correlates with this. That is our eventual agenda.
Yeah.
Okay. So I think okay. So we can have this on this thing, so that we know that our goal is to achieve something like this. Though I doubt with linear regression you can actually do that. But anyway.
Yeah.
Anyway, we are kind of out of time. I just sort of want to ask if anyone else, like, there's only one other person, Harish. If Harish wants anything, any comments?
Actually, no, sir, but I was like expecting this one day graph so that since you are doing the work, so you can understand what exactly you are doing. But from the beginning, I was having some doubt that how exactly we are getting into the conclusion. So the refinements, I got confused. how to refine the data,
Mhm.
but now I understood little bit. And the overall picture I'm understanding, sir. That is the main thing. And how to get the ideas to get some output from the data. The overall picture I am getting. Maybe if I work on the problem, then I will get more.
Yeah. So I will send this. I'll just clean a little bit the Jupyter notebook and send it in the Google groups.
Yeah.
Usually I got confused because Krishnan already worked on that. So from where we are starting, I was a little confused about it. But at the end,
You should have stopped us immediately because I thought because you were there last time, that's why I didn't try to explain.
I understood that. After that, maybe you worked in the home, so which I don't want to discuss that because I know that after some time I can understand. So no need to discuss it.
Okay.
I understood
No.
at the end. I understood what you are saying.
Yeah. No, I didn't do much at home. In fact, I just did a little bit of resampling and that's all. But anyway, but anyway, we can actually stop even at that point because at the end we are only 3 of us. We can explain. If it is 10 people, you can understand. If everybody asks, then we will probably not be able to move. But we are only 3, so it will be fine. Okay.
I think because I'm sitting idle and this one is working very hard for that. So better I try to get some problem stations from next class. I'll work on that.
Sure. No.
When are you starting your PhD again?
Jam, sir.
Oh, I see. So, okay. So, another 2.5 months?
Yeah. Actually, here I'm working on a problem statement.
Oh, you lost him?
Yeah, last time also the same thing happened.
Yeah, I think his this thing, Wi-Fi breaks after too much.
Okay.
Could be. Anyway, let's give it like 30 seconds, see if he comes back. Otherwise, conclude. Yeah, okay. I think we have like a decent. He's back.
Yeah, he's back.
Yeah, okay.
Yeah, go on.
Yeah.
So I'm working on some product development related work. So need to finish that because the responsibility on me so that I can finish quickly the end work. So this is IIT project which related to the hydrogen technology. The science part came from the chemistry background where if we mix the 2 chemicals then hydrogen produces within fraction of second. So we are in the process to make that science part as a technology. So my part is to use that science and develop a product. So now we are working with the IC engine. This is not new that hydrogen is injecting into the IC engine, but generally they use high pressurized cylinders to store hydrogen. Now we are eliminating that problem. So pressurized hydrogen is very big problem because it is highly explosive.
Yeah.
Now we have liquid containers where whenever we want to produce hydrogen according to the demand, we can produce. So we got some interesting result that we are injecting into the diesel engine now. So we got 2%, 1% efficiency more than the pure diesel, and the hydrogen with the hydrogen the vibrations and the pollutants are coming down. So there are some technical issues that still need to work on. So I'm busy with that work. So since I have only 2 months before that I need to finish.
Okay.
Yeah.
Anyway. Okay then. So I think we will conclude. So see you next week, and as always, thanks for coming. It's a nice group we formed. So yeah, really nice to see. I hope this continues even after you start your PhD. For the first 6 months, you might be very busy. So let's see.
I'll join, sir. Even I can't understand anything that I was join because there are some important things I can take from this classes.
Okay.
It's nice that like analyzing some problem statement and getting into the conclusions is like the interpretation how you are doing is really great. So that's why I just joined.
Okay, sure. Nice to do. Anyway, okay. Thank you so much and have a nice evening, everyone. Okay, bye-bye.